Good morning, everyone. Hello, Vinod, am I audible? Hello, Vinod.
Definitely, I can hear you.
Okay, Mr. Satya, good morning. Welcome to today's session, sir.
Good morning.
Yeah.
Thank you.
Good morning, everyone, and a very warm welcome to today's session. Our mentor for this morning session is Mr. Satya Tumula. And a little about to get to know about him. He is a seasoned engineering leader with over 20 years of experience. He's been a site leader, head of engineering at Shoretel Communications. He's also been the assistant vice president at Artisan, handling Motorola projects. He has 20 years experience as Motorola as head of multimedia software technology. Mr. Satya also specializes in bringing up high quality teams that excel in engineering and operate high up in the value chain. He loves nurturing technology leaders and motivates them to give their best. His teams build large scale, high quality communication systems with multi level capabilities. He comes with a management degree from IIM Bangalore and also a master's in engineering from IIT Delhi. He is the one who is going to speak to us on the topic for the day, natural language processing. So, without wasting much time, students, help me welcome Mr. Satya Tumula. Over to you, sir.
Thank you, Daphne. Thank you, Isert. And good morning, students, and whoever else has joined this webinar session. So I guess there's a bit of an expectation, maybe in your minds about what would be covered today. I intend this to be not just one lecture, but maybe at least a couple of them, and if time permits, maybe more, where we talk about the natural language processing in detail. But today's session, I'll keep it short and introductory, and you can probably pitch in a lot more questions from your side and stuff like that, and subsequently we can go into the depths of a particular this particular technology area, depending on your interest. So we are I represent a company called Novo Labs, which is into about 3 products. We are actually creating 3 products. We are creating a natural language processing based voice virtual agent, and we're also creating a video conferencing solution, which is going to be AI enabled, and also AI enabled a scan product called Dolphin Scan. So we call them AskAI, Dolphin Scan, and Dolphin VC. And they are like kind of built from the same AI platform that we have actually originally started for the first product, AskAI, and then being used into various applications. So that's the background. I guess most of the people that are with any background or any subject that you have taken in natural language processing are any speech related technologies. You can actually raise your hands. This is a webinar platform, I guess, right, Daphne? This is mostly a webinar platform. Is it a regular meeting system? Whoever has
Yes,
whoever has some exposure to natural language processing or speech technologies, can you guys raise your hands in the system?
students, I encourage you to make this session very interactive, to cooperate with our mentor this morning. Raise your hands when asked, and or type out in the chat box, whichever is convenient for you. Let's make it interactive and interesting. Thank you.
Okay, so Zoom actually gives a provision to raise hands. Can you guys see that? Okay. I don't see anybody raising hands, so I kind of assume that nobody has any background in natural language processing. Um, so um, so let me just go a little bit into that before we go into the rest of the presentation. Um, uh, so natural language processing is a branch of computer science which deals with being able to process any natural language text. For example, you have let's say I am actually speaking to someone, and typically you speak to a human, but you should be able to speak to a machine as well, and the machine should be able to understand what you said and then be able to do a decent amount of I mean, we don't expect it to be perfect, but eventually the goal is to make it perfect. But as of now, we expect it to do a decent amount of understanding of what you said, and then be able to respond or be able to do certain actions based on what you requested. So a typical use case could be that you are calling a contact center at the bank, and the bank, of course, gives certain accesses to that system. So it can actually do things like getting your balance, or maybe changing your pin, or checking the status of some transaction that you initiated before, things of that sort. It should be able to go and then query the backend system, a database, and then be able to fetch the information and then play it back to you, right? That's one use case. The other use cases would be being able to translate. So there are translators that are almost real-time translators today. So you carry the tourists, you see the tourists carrying them. So they go and then say something in Japanese, it will convert into English, and thrust it into somebody's face, and then you say something in Japanese, and then almost within a matter of seconds, it'll actually play in English, right? So another way around, of course. There is also the use case of being able to query a database. So you go into a system, a web portal which contains let's say a lot of pharmaceutical data. So you can go and then ask a query in plain text and then be able to get an answer. And like, it's slightly different than Google. Of course, Google also uses NLP, but this one is something like your answers will be pretty accurate and to the point, unlike Google, which actually gives you a lot of possible records, and then it doesn't really answer you. And of course, you see Google already doing those things nowadays, like you get short answers. You ask for, like, at what age did Messi retire, or I mean, just giving an example, like when did Maradona die. Some of those things, it actually just gives an answer, with a very precise few worded answers. But that's natural language processing for you. In this system, you can ask a question like, oh, what is the effectiveness of the medicine that has been administered, like maybe some kind of a sample which is being taken for clinical trials. So you can ask, what is the effectiveness of this in the Middle Eastern region, in the 90s, right? Something like that. So, or which in which all movies that Elvis Presley maybe acted, or whatever it is, where the director is younger than him. So like all kinds of combinations, and that are possible. So it is a very I would say unexplored area of engineering. There is still a lot of work to be done, very interesting work to be done. In fact, I think somebody asked Bill Gates, if you were to continue in engineering and be an engineer, what would you have done? So Bill Gates' answer was that I would have done something in NLP. So it's very subject. It's a very strong and interesting subject for engineers and researchers, and very unexplored. So there is a lot of work that can be done, a lot of research that can be done. So with that introduction, we will start with what are the with the evolution, and then the various parts of the presentation. Let me just open that. Yeah, so please ignore, I have not made a specific presentation for this, but I've just used some presentation template from our company itself. So you can ignore the company name and those parts, but primarily look in. So like I mentioned at a high level, it's a branch of science and computer science where computers analyze, understand, and derive the meaning from human language. So there is a hierarchical structure of the language. So several words make a phrase, and several phrases make a sentence, and sentences convey ideas. So idea is to understand the idea that a human is trying to convey, and then be able to make any actions on that. If you look at the context of NLP within AI, so I mean, obviously, a lot of you guys are familiar with AI because you probably have subjects and then stuff like that, and it's a very interesting field. And then I picked a picture from the internet, which is basically it determines there are deterministic rules. There is robotics. There is a regular predictive knowledge management, and then and there is natural language processing, and there's of course a machine learning part of it. There's a very thin line between AI and then machine learning, and AI is generally the a larger uh, I would say field under which machine learning is one of the subfields, but many people tend to actually mix them. So within NLP, if you look at it, there is the sub technologies which are kind of considered to be part of NLP. If you take text to speech, in the traditional text to speech was not actually part of NLP. But as we started, as TTS started evolving, it has become part of. It has taken a lot of deep learning, concepts into it, and it just became a part of NLP
So,
now.
sorry to interrupt.
Mhm.
Your screen is not visible.
Oh, screen is not visible. Oh, I'm sorry about that. Oh, yeah, I actually was not sharing, so uh, good that you pointed out. Okay, can you see it now?
Yes, yes. Thank you.
Yeah. Yeah, sorry about that. I didn't realize I was not sharing. So this is the piece that we are talking about, where my cursor is. There is text to speech, translation, speech to text, and then image to text. I mean, I would say the first three of them. This is basically another part. So like based on this, there are the applications that are coming in on the right side, which is automated speech, automated writing, and then being able to get the likely answers. And there is kind of a deep, I would say, mesh that one layer actually leverages from the other layer. So like I mentioned before, text to speech is one of the very fundamental um, building blocks of natural language processing, and that's one of the areas where there is a huge scope for improvement. So you have probably seen, I mean, from in the early 2000s, where in fact the text to speech has been there for a while. It has been there since I did my BTech, I mean early 90s, to a time where now where the computing has become affordable, and then it has become generally available. So at the earliest stages, we used to use the regular speech processing techniques, and be able to come up with phonemes, and from the phonemes we were able to do a lot of compute to be able to actually come up with the words. But now with a lot of amount of training, there are techniques that actually allow you to come up with words directly from the speech signal, rather than converting intermediary into phonemes and stuff like that. So there are a lot of hybrid techniques as well, in which people do a combination of phonemes and deep learning based techniques. And I mean, basically the traditional speech processing and the deep learning based processing, and then be able to the output, right? um, in the whole technology chain, in addition to TTS, the next layer, right, is the regular the traditional natural language processing, right? Just give me 1 second. Somebody has written something. Okay, yeah. So I guess what I will do is you can keep your questions coming in, and I will. Do you see any part of the screen being hidden right now? No, right? Do you guys see a block patch or something like
No,
that?
it's fine, sir.
It's fine, right? Okay, yeah. I just opened the chat window, so I just want to
Yeah,
double
it's
check.
fine.
Okay, so you guys can keep the questions coming in, and I will take them in a bunch, right? I mean, I would probably stop in between, take them in a bunch together, and then again move on. I will not be able to answer in every question as it comes, but I will cover them. So yeah, so the current question is, do we have a separate version of the program for each language, and then where appropriate for each dialect of a language? So the answer is yes and no. I mean, we could do it the way we want. So there is a step called language detection, which happens just before we do the rest of the natural language processing. So whenever somebody utters a word, um, so the if you do the deep learning based techniques, in if AI model has been generated with the data from a particular language. So if I actually do the generation of the model with a particular language, let's say I do that with English, then you would the model will be able to do the speech to text conversion only for English, right? It all depends on how you train the model. um, but what happens is there are certain words that actually have different meanings in different languages, and so the system might get confused. But in those cases, what happens is the system would look at the adjoining words, and then based on that compute the probabilities, and then be able to automatically determine the right word, I mean which language word to pick, and then it will go from there. But more of course, the common approach is to first detect the language and then apply the model that basically belongs to that language. And the challenge is that the languages are generally not independent, in the sense, when we speak in Kannada or Hindi, we actually use a lot of Hindi English words, right? um, so the model has to be done in such a way that all the words that particular set of speakers speak are kind of loosely, like you can, like people call it as Hinglish, right? Hindi plus English, where the majority is English, but there are a lot of Hindi words, and other way around also, where majority is Hindi, but there are a lot of English words. So we will have to look at more than actually language, but you could just say that uh, creating a model for Indians that live in the northern part of India, right, could be uh, where there is Hindi plus some spattering of the words in English, and similarly the case with Kannada as well. So those words that are borrowed from other languages also have to be baked in as part of the model. Otherwise, it will not be very effective. So we use English so frequently in our words, in our daily speech, that kind of they become like part of Kannada, you could say. Also, the even in that particular, also, like looking at a sentence or maybe the first paragraph of what what this machine is able to comprehend, based on that it can figure out that it needs to convert into detect the language automatically and then apply that model majorly, right? So I'll come into one of whatever we did, where how things have been done, so that kind of gives a decent idea. And the same applies with dialects as well. You need to create models for that dialect, to be able to make it very effective. Since and this is actually becomes nothing without the a context, right? People actually look at corrections. You would have probably seen that in the. Give me 1 second. Yeah, give me 1 second. So there is the you would have seen it in Google. When you say a word, on the screen you will see some text, but when you say the next word and the next few words, you will actually notice that the first word that was actually detected is auto corrected to some other word. It's because it is constantly doing taking the entire sentence that has been uttered so far, and relooking at the previous words retrospectively, and then making corrections to them, right? So it could be like, what is your name, right? I mean, and then where do you live? So there is a possibility that it might have taken the name as some other word, because the way you said name could have been like some other word, maybe maybe net or something like that. I don't know. I mean, it could be any word. And then, where do you live, for example, right? So the moment we say where do you live, it actually go back and then change that net to name, right? Because in its database, in its training set, it's very likely that when you ask for what is and then where you live and all those things, then probably something that sounds with phoneme na coming in is very likely to be name and then not net, right? I mean, so that's a kind of uh, intelligence that it uses to be able to change it back to name, right? So that's the kind of answer to that question. So going to the next slide. Yeah, so the context of NLP, and basically because there is this lingo of a lot of so the AI is a overarching field that kind of encompasses all of them, and then within that there is ML. Within ML there is deep learning, because there is machine learning that is there with and without deep learning, and then there is natural language processing, which is kind of leverages ML/DL, and also it has got other techniques that are not machine learning based techniques, but NLP is a branch of AI in that sense. So it is basically a subset within AI. So I hope that gives a clear context of what this is. And so like I mentioned earlier about natural language processing based models, as well as models which are both classical and deep learning based. In a classical NLP, again there are models, right? But that's it's these models are typically not multi-layer based, right? um, give me 1 second. And so basically it has multiple layers as far as the dense the deep learning based models are concerned, whereas in the regular ones you actually see a lot different situation. And so take an example. So there is the feature extractions. It says feature extraction here, it's a typo. And they can be for different language based, and then you have the uh, some amount of pre-processing that happens, which is, I think pre-processing is a technique that pretty much is used even in the deep learning based models also, but it is specifically shown as a step here because the number of pre-processing steps that are there in a regular classical NLP is much higher than the pre-processing techniques we would see it in a deep learning model. In fact, there are deep learning layers that actually do pre-processing internally themselves, but of course, people have questions about their efficacy, though they actually use the traditional pre-processing techniques there. And the output, you can see that there is sentiment, there is classification, entity extraction, translation, topic modeling. These are all the applications of NLP, right? You can use NLP for one of the very classic places where NLP is used is understanding the sentiment of people that are actually giving comments on an e-commerce website, right? Or maybe the pollsters, basically poll analysts, right? Look at the social media websites and be able to understand the sentiment of the people and which way the most of the people are going, right? And so there's also a lot of these bots that actually create comments in social media websites and all those things. So there is always a possibility you might get wrong inferences by looking at the social media content. But we look at assuming that the content is genuine. Based on that, you could actually get the inferences by using the sentiment analysis. You also classification techniques, which are things like by looking at the paragraph of text, we can say, is this guy positive, or is this something which is sounding like a science paragraph or a social studies paragraph, or whatever, right? I mean, so what is this guy talking about? Is it biology and stuff like that? So that's a classification. Entity extraction, I mean, I'll come to the concept of entities, like, for example, you could have names like I live in I mean, my name is Raman and I live in let's say Ayodhya. So the names and cities and like slash places are all of them become entities. Like, for example, I would say I would like to book a ticket from Delhi to Bombay, or I can say I would like to cancel my ticket, and so all of them become the various entities, and there are intents, right? So the whole intent is to book a ticket, and the entities are things like origin, destination, date, and the class of ticket, and the morning, evening, which flight you would prefer. All of them become entities. So in a system, when you are becoming when you want to actually extract the entities like that, we need to actually take data and give a sample data. And before feeding the data to the system, I need to do the markings, right? It's called annotation. So I need to annotate the system, say, okay, this is my entity, and this entity is of type like origin, destination, and then I need to mark them and then feed it to a system so that the system understands that, okay, this particular entity comes in this context. So it will build the model to take those relations between various entities. And in fact, those relations themselves are actually built in. Like, for example, if I say from something, it understands that to be kind of, anything that comes preceded by a from is an origin. Anything that comes preceded by a to is a destination. So it kind of system learns that model. The model learns that those relations within and then keeps it part of that. So whenever you give, now that model is taken and then you put it in a real life situations, and when somebody asks this, then it'll come back and then give the output as the origin is Bombay, right? And translation is a lot complex field, and there are the maturity of the translations is so good nowadays that you would not I mean, I wouldn't say like in all the cases, but for certain languages it is very good. But we do see that the translation is not as good. Like, for example, the Microsoft meetings actually have an ability to translate on the fly. And but you would obviously see that the ability of the translation is probably like 60 to 70%, but it's good enough for somebody who doesn't know the language at all to be able to make out something there. But though it's not that it can be very accurate. So now coming back to this particular topic of the differences between the two, you can see that the language technique, the NLP techniques, this is the of medium complexity, the one which is basically classical one, but it doesn't involve any training, right? Very little training. The models are actually preset, whereas the deep learning is fairly quick relative to the regular classical NLP. Deep learning is actually faster in when you're actually running it, when you're running the models. But generation of the models is very complex. It takes months together to generate a model. So there are like, if I have data today, and I just give me 1 second, please. Sorry, a small distraction. Um, basically, there is a the complexity as I was talking about. There is a possibility that you might actually leave the model training started now, and then you will actually get a result a month down the line. Especially when there is a data that you are actually collecting the data from. You probably end up having gigabytes of data. Like for example, the being able to do the entity extraction in a pharma kind of a project that we were involved in. So we used to have the data coming in from various field trial or a clinical trial reports that used to be fed in to a training, and the typical cycle we had was about 27 days by the time we actually get the model output. Even something as simple as being able to train images for being able to do an object detection, it used to be something like 2.5 days, right? So that's the complexity there. So moving to the next slide. Yeah, this is more like how the evaluation happened, and a little bit of a text that we're talking about. There is the broader field of natural language processing, on which we have the natural language generation as well as natural language understanding. This is basically, there is also, of course, a little bit of natural language processing itself, which is kind of on its own, a separate, I would say, categorization within this. Um, so within the natural language understanding, which is where most of the interest is right now, there is the ability to be able to get the phonemes and then be able to, based on that, figure out the semantics, and and then of course I'll come to that detail a little bit later as to how that works. But yeah, this is basically at a high level different branches out of which natural language understanding is the most the current one. And so if you look at it, the stack, natural language processing stacks, there are multiple I would say solutions available in the market today, but at various levels of maturity. And they're all mostly, I would say, they are available in the form of libraries. There is no system that you can build, a good system that you can build by using any one of them in isolation. So you have to basically use a combination of them um, to be able to get an effective solution going. For example, I'll come to an example later, but let's start with the stack. So there is a CPU and GPU, and I think all of you guys probably are very familiar with this by now. What is a CPU and then what is a GPU? GPU is something that is used to create, that is used for being able to do a lot of compute together. So I mean, you would have seen these NVIDIA GPUs, and then there are a lot of there are a few other companies as well that make these GPUs. So they are expensive, and then they have got lots of compute CPUs kind of embedded into that with some kind of hardware accelerators, which, like you can say, are specially built for multiply, accumulate kind of operations, or maybe a specific series of operations have been hardwired into that particular chipset, right? And there are frameworks like popularly known, like, I mean, many of you know TensorFlow from Google. And then on top of these frameworks, there are topologies that are built, which are basically, I would say, a lot of these topologies are kind of applicable to certain fields, but there are also the, for example, the key value network. It's a very generic one that's used across multiple things. Or there is a MEM network, or the match LSTM. Then there are the NLP components on top of it, which are essentially, I would say, the building blocks, the first level pure NLP stuff that comes in, chunkers, the segmentation, semantic segmentations, the parsers like a spacies, and various others, NER, and the intent detection, intent identification kind of a thing. And then on top of that, there are I would say high level tools that are built. These are you can say are to give you an indicative implementation rather than a full implementation. Let's say, for example, question answer, for example, can be like a pretty close to a full implementation, whereas NP to VEC, right, is a building block. and NER or any expansion again is a building block. So goal-oriented dialogue, for example, is a again like a almost like a full implementation. So what do we say goal-oriented dialogue is? Like an example for that would be like I want to do a ticket booking, flight booking, right? So there is the end goal would be to book a ticket, to cancel a ticket, to find the status of a flight, or things. There are certain things that you can do within that. Let's say there are 10 different actions that you can do within that. So it becomes a lot easier for the system when a goal is known, right? But I can't build a model for a friend, right? But I can build model for a airline agent. But a friend, we can talk anything, just about anything. Could be subjects, could be personal, could be about your college, and it could be a lot of things that you can talk. So it's a very open-ended thing, right? And it becomes very difficult in natural language processing to simulate your friend, or your maybe a relative or somebody like that, where the conversations are very open-ended. But uh, so that's one of the very common use cases, like doing a service desk, right? IT desk, an HR operations person, an HR help desk kind of a situation. All of those things are a lot easier because we know what are the questions that are likely to come, right? And then of course the usage, which is of course we create these Python libraries or whatever language. It may not be in Python, it could be in Java also, it could be in any of them, but of course Python is a lot richer for NLP tools. And then there is a REST service, which is basically just for the consumption into applications. So that's a very high level stack. Like I mentioned this before, what NLP can accomplish. It can accomplish like you can do translations, you can do named entity recognitions, relationship extractions, parts of speech tagging, grammar corrections. Lots of use cases. We just got some of them that I can quickly put together. And then there are, if you look at the deeper applications of NLP, and there it is a lot more in I would say the more common applications, the end applications are like to the right, and the ones to the left are more like tools that are enabling more than applications. I would say these are mostly tools that are enabling the applications on the right. So like we talked about dialogue system, the question answering system. So there is a typo here. And then there is a translation, and then the natural language generation, and so on and so forth. There is image captioning, and there is essentially the CC, the closed captioning in a in a for the movies. You can actually see, you enable CC on YouTube, and then you get the output text that is actually shown on the screen, and that's mostly speech to text conversion. And then on top of that, you apply natural language processing and then be able to get a sentence. So you just do a pure speech to text conversion, you actually get lot lesser. I mean, you will be very surprised to look at the text that actually comes out of speech to text versus the text that you get out of after processing with NLP. So we talked about summarize blocks of text. I'm just basically some simple NLP projects that are possible. So again, a lot of this information is available on the internet. I just created a lot of this content by looking at the information from the internet. But of course, like it's something that more specific examples and stuff like that is something that I would actually cover in the next session. But you can actually like summarize blocks of text using summarization tools. You can create a chatbot using Parsi, McParse. Again, some of these are actually been there for a while. There are other tools as well that have actually come out, and we have seen a lot more I would say sophisticated tools than what, let's say, today Parsi McParse does. I mean, we personally have built tools which are, I personally, or my company has built tools which are actually, lot advanced chatbots than what we have seen in the open internet. But that these are good enough for you to get an idea of what it takes. But most practical applications, you just cannot use them as it is. You have to really, build something, with a very custom application. Then you can identify the type of the entity being extracted, like I mentioned, person, place, kind of a thing. Identify the sentiment of a thing from negative to neutral to positive. And they're talking about a stemming and then lemmatization and then some of these techniques, which are basically some things that we can cover later in the next session. But at a high level, what are the various technology pieces, or I would say the tools that are available in NLP? There is Apache Open NLP, or there is NLTK, and there is Stanford NLP, Mallet. There are multiple things. There is, like, the Google has it, AWS has it. Like today, a lot of those the cloud providers, including the Microsoft has it, IBM has it. IBM Watson is a very well known and very long standing NLP tool. And I mean, you can also, like the different companies or different projects choose different tools, and then they kind of invest in that, and then they kind of go with them. But pretty much all of them provide you anywhere between 60 to 95. I mean, some of them you can actually provide 99% accuracy as well. But on a consistent basis, you can actually see around 90%, 90 to 95% accuracy. So build your own social media monitoring tool. I mentioned this before. Give me 1 second. Let me just switch on the light. Yeah, and the IT help desk, contact center automation. You probably would have seen that some of the banks now have moved to natural language based tools, or contact center agents. For example, I don't know if you have used Kotak Bank, for example, and HDFC also to some extent. They use this technology. You can see that initially it's answered by. See, there's a difference between uh, IVR system, right? Interactive voice responsive system versus the natural language based, virtual as agent, right? Not a virtual assistant, but virtual agent. Virtual assistants are mostly on your phones that are actually kind of doing things on your behalf, but agents are the ones that are kind of work on behalf of the your entity that you are working with, like a bank or whatever it is. So in a IVR system, the strings that need to be spoken are actually pre-built, right? And they don't understand. They will only understand they may understand words. In some of the advanced IVR systems, they understand words, but they don't understand sentences. But they will understand the DTMF keys that you press on the phone. They understand you press 1 for this, 2 for this. That's all they can do. But if the moment they pick up and say, and then say, hey, welcome to ICICI Bank, what would you like to do? Then I want to say, hey, I want to look at my balance, right? And then it'll ask you, okay, what's your account number? And I will say, 01234, whatever it is, right? So all that will feel like a regular conversation, and you have an ability to be able to significantly, you have a freedom of being able to use your natural language text. But what happens is, many times you see the system will coming back and say, sorry, I did not understand what you said. Can you repeat it, right? That basically means the system is not mature enough. Are basically not able to, system is not doesn't have a strong enough model to be able to model all kinds of the possible utterances that can come in from a customer, right? So the more freely you can talk, the more mature a system is, right? That's the way it is. Then we talked about the recruitment process automation. There are some tools that have just started coming in the market where when you are actually applying for a job, to the stage where you exit for the interview process, to the stage where you actually get an offer letter, entire process automated by bots, including sending you reminders, sending you emails related to the interview time and stuff like that, calling you 15 minutes before. And if there is any postponement, calling, and all kinds of things are actually automatically automated. So the next one is yeah. Um, just give me 1 second. Yeah. So yeah, like I mentioned, natural language interfaces to extract information from text documents. And then you can answer a question. It takes a passage out of a text and then question as inputs. So anyway, so this is probably something that I already spoke. So let me skip this. Um, I've just taken this passage from internet. For example, you can give a passage like The Matrix is a 1999 science fiction, blah blah blah, and then it talks about who acted in that film, and then you can ask a question. So you give this passage as the input to the system, and this is the question: who stars in the Matrix, right? So you actually get an answer like Keanu Reeves and blah blah blah, all those 4 or 5 names, right? Um, so it is able to understand the sentence and it's able to adapt. And so this is called the machine comprehension. The machine is actually trying to understand a particular sentence that is given, and then now it is ready because it is comprehended. It is ready to answer. So you have the reading comprehension questions in CAT. It's something similar, right? So you give something like this, and then you ask a question, you get an answer. Um, then the other things would be that you actually give again an input and see what is the, like for example, um, a hypothesis, right? That you want to check based on some premise that is given. Like in this case, the premise would be this descriptive piece of text that is given above, and like I'll get you an example later in the next slide. But you will be able to see whether there is the hypothesis is a contradiction, an entailment, or a neutral observation. So example is two women are wandering along the shore drinking iced tea, and then the other one hypothesis is that the two women are sitting on a blanket near some rocks talking about politics. So given the premise, and the system actually understands the premise, and then when you give a hypothesis, it'll actually give an output, which is like either contradiction. So it'll say contradiction is with a probability of 0.97, and entailment is with the probability of so and so, and then neutral is with the probability of this. You add up all of them, you get one. But what it says is that looking at the probabilities, it basically indicates that these two sentences are contradicting each other, right? It doesn't mean the contradict means like the exact opposites, but it basically means that what you are saying versus what the hypotheses, they seem to be kind of not in alignment, but rather so one is saying wandering, the other one is saying sitting, right? And one is saying you are drinking, the other one is saying that you are talking about politics. So they're like not at all same. So if they are not at all in alignment, then it's a contradiction, right? For example, if you are running, also can be a contradiction, right? Not necessarily sitting. But but if you say walking, then you will actually get something like a entailment, right? So because walking is kind of similar to wandering, so it looks at those things which are very very likely to be kind of giving a similar meaning, right, rather than different meanings. Different does not mean opposite. So there is also semantic role labeling. So I'll take you to example straight away. Like the cat ate the dog with ketchup, right? So you should be able to actually split this into what is a verb, what are the what is the description, and then so I'll probably get a little bit more in detail once I explain the few other examples. So we are actually splitting this into various arguments, like the cat ate and the dog, and then we start actually giving them some kind of tags to it. So there is arguments, then there is a verb, and then there are arguments. That's a very basic building block. But a more I would say the detailed version would be something like this. We would like to introduce this to this NLP library. right? So you can see that each of them is being split into some kind of um, parts of speech tagging, right? So noun, and there's a verb, there is adjectives, adverbs, and then of course there are these mixed form, the prepositions, and then all kinds of parts of speech have been identified. Not only have been identified, have they been identified, but the linkages have been put between them. So the arrows that you see above are kind of like you can see an arrow here. Introduce has not been linked to this, but introduce has been linked to library. Okay, so it's like we like introduce library, right? That's the a basic sentence. That is, we is linked to like, and then like is linked to introduce, and introduce is linked to library. So we like introduce library is the basic form. Then what we do is in a if I were to do a lemmatization and stemming, right, I would actually take the sentence, split it, I mean remove all the unnecessary stuff, and then I would leave with it will leave with these four words, right? We like introduce and library. It starts with that, and then once you get those basic words in there, then it will start creating linkages, um, with the other words that are surrounding. For example, this NLP library, right? NLP, for example, is a you can take it as a an adjective to library, right? It is basically qualifying library, trying to give what type of library it is, and this again is something that is kind of qualifying this. And similarly here, two is something which is basically connecting introduced to like, and then again like is something connected with we with a wood, right? And then so this is wood is basically something something that is in a way qualifying like, right? So the taking minimizing a sentence to a bare minimal form, and then be able to create linkages among them, and then be able to identify that what is the parts of speech. All of this is something that you cannot write with a regular functional programming, or where you can actually say a logical flow that you can put in, and then a logical programming, you can say. This is something that you can actually do with a deep learning only, because you basically just take millions and millions of lines of text, and then basically do the POS tagging on top of that, and then train the system, and then be able to give this sentence in, so that the system actually gives you the POS tagged output, right? And so that's something that is actually something that we could do, and then figure it out, and then get that stuff. We were able to create a very good language parser, building it from scratch, something similar to what the this particular thing. This is basically from a tool called Spacey. You could do that. And so this is about a very high level overview of natural language processing. And I've really not spent any amount of time going into the depths. This is just to give you a very high level view of the technology and stuff like that. And then I'll take a few minutes talking about what we do. So we have a platform called AskAI, which is a conversational AI platform. That is something that we are developing in house in our company. So the idea is to converse with humans on behalf of service agents in natural language. So it learns based on usage by humans. So as and when the system is being used, it becomes more and more sophisticated, because it learns. There is a feedback loop in there, analyzes natural language conversations to derive structured inferences. So this is like I talked about goal-oriented dialogues. So basically, we do goal-oriented dialogues, and the idea is that will save cost, improves efficiency, because the contact center agents are the ones that get bored. They have the highest amount of attrition. So you become a contact center agent, then you're not liking your job very, very often, because you're doing things the same thing again and again, and then there is frustration, there is attrition, there is all kinds of things that happen. So we want these agents to take that mundane task and then be able to make the customer's life also easier, because it is talking to not a very irritated contact center agent and then stuff like that, but he's getting the job done also very quickly, because it doesn't have to wait for being in the queue, now you are the 41st person in the queue, and then you are the 27th person in the queue. There's a lot of waiting that is there. Press this, press that. It's very irritating. So you can just imagine being able to actually pick up the phone and then say, hey, what's my balance? And the system tells you this is your balance, right? It's a lot easier experience. So you can see that, let's say, 8-9 years down the line, you can see that you are actually talking only to machines. And if you're talking to an agent, right, a human agent, it's only for very difficult tasks, right? Something that the machine cannot understand. And those are the cases, of course, that we would actually go back with, yeah, probably more complex tasks that machine is not able to resolve. So we have a hybrid approach, leveraging semantic and then deep learning based techniques. We combined about 25 techniques to be able to create a model rather than just simple find patterns kind of a thing, but a sophisticated model is built. We have these use cases that can be done: customer support, technical support, concierge services, interviews, surveys, engagement services, analysis of conversations, all kinds of things. And this is an architecture. I'm not obviously can't give my architecture here, so I just picked the GKS architecture. So just to look at various layers, there is an ingress controller. This is basically more of a building a web server, and the conversation session manager that actually talks to an NLP server. Then there is an audio video processor which actually feeds into a speech service that eventually stores into a global cloud storage, or feed this information into a question graph, which is basically something that you will actually get from the data stored in the storage. And then there is a question context analyzer, and then be able to actually answer the question. So the entire thing is a combination of the speech to text conversions, graph analyzers, parsers, and like things like entity extractors, right, and intent detection engines, and then answer generations, and various pieces like that together make a complete system, right? This is our platform overview, which basically we have a video input or a text input or a speech input. If it's case of a video or a gesture or a speech, it will get transformed into text, and then it will feed into our natural language processing core engine. And of course, it actually talks to data to be able to understand. I mean, that it's very data intensive. A lot of storage will be required, and then a lot of context specific information is required. Every context will have any specific when I say context, right, it's a vertical in which it is applied. A banking has got a different set of data. There is a IT support has got different amount of data, a different kind of data. HR bots have got different kind of data. And anyway, I don't want to go too deep into it. And we just talked about contact center agents and interviews. And in fact, we can take it to a level where you can actually do a first level interview with a machine rather than actually an interviewer, a human interviewer coming and interviewing. And we did apply it in contact centers. We also used it in things like a application like a faucet repair, where you need to actually get your tap repaired, bathroom tap repaired. We could get to a stage where you can take a picture of the tap and upload the image of the tap, and then it will figure out what is the make of the particular tap, and then be able to suggest, this is based on the problem that you are describing. It will be able to actually do some corrective actions. And if it's not possible, it'll be sent to a technician figures out by looking at the tap what it is, and then be able to get the spare parts and then come in within one visit. Your thing will be done, rather than technician coming in, looking at the tap, figuring out what is the issue, and then going out again, going to the shop, buying the parts, coming and then fixing it. This could be done with kind of one visit. And then we also implemented a bot for airline booking. Things like book a flight from AIA to KGIA on 25th February, and book a flight from Kempegonda, I'm just giving you, right, museum to Red Fort. I mean, you could do a lot of things. It'll figure out that Kempegonda museum is in Bangalore, Red Fort is in Delhi, so it'll book it from here. And you can do it for the place of interest rather than city itself. Or you can say book it from Meenambakam to Devanhalli rather than saying book it from Madras to Bangalore. all kinds of stuff which are innovations are possible, which is basically by deriving the context, or I can say from BLR to CCU instead of saying Bangalore to Calcutta, and so on and so forth. We did comparison with various, and I don't want to go into those details because this proprietary information, but at a high level, yeah, this is what chatbots do, and I don't want a lot of this detail as such, but yeah, you can look at let's say building a very basic system to very sophisticated system using these technologies, and it's a very, like I mentioned, it's a very interesting area for people to be associated with. Okay, with that I finish my monologue. It has not been, of course, not a lot of questions have come in, but I think I'll open it up for questions, so feel free to ask. And Daphne, if you want to open the mic for people, we can do that.
Sure. Thank you so much, Mr. Satya, for this session. I'm sure the students learned so much. And yes, there could be a lot of questions on their mind. We open now the floor for questions. So you could type in your chat box, and Mr. Satya will be able to answer them. And I request the ones who have joined in YouTube as well to just type them out, and I can read it for Mr. Satya to answer them. Yeah, sure. Thank you.
Okay, go ahead, folks. Okay, I guess what I think you can do is, if there are no questions, there are two possibilities. One is you did not understand anything at all, or you understood everything. I guess if it is the first case, maybe you guys can actually put in suggestions on what can be covered. If you guys want a detailed treatment to the subject, or you want any particular subtopic within that, I can actually go into the detail, because obviously you being engineers might actually be looking for details. So let me know. You could actually put in suggestions as well in there. These are the areas that we would like to go into deep, or we did not understand this particular area. Can you cover it more in detail? So those are the things that we can definitely take as a feedback and then take care of it in the next session.
Yeah, sure. That would be great. And we have also, posted in the feedback form on the chat. So students can actually, fill in the feedback form, and we could share it with Mr. Satya for feedback. So he can address it in the next or the upcoming sessions. We can do that. The same for, the students on YouTube. We will just give it a minute or two, Mr. Satya, before we close the session in case they have any questions.
Absolutely. Yeah. So I was just wondering, this doesn't have an ability for people to raise hands, the tool?
Yeah, one Jayashree has raised her hand. Yes,
Okay.
Jayashree, you can unmute your mic and ask. Hello. Yes, Jayashree, can you unmute your mic and ask?
ಮನುಷ್ಯನಿಗೂ ಹೋಗ್ತೀನಿ
Okay. So I think there was an utterance, but I couldn't make out.
Okay. There So we will just wait for the feedback forms, Mr. Satya, and we could share them with you and we could take it forward in the coming sessions. And thank you so much for your valuable time. And it was so much of learning. It was intense learning today. And I hope it's benefited everybody on this program. We extend our thanks on behalf of everyone in ICER and wish you all the best. Thank you so much.
Thank you, students, and thanks for your active participation in this. And thank you, Daphne, for coordinating and making it happen. Bye.
Thank you, sir.